Hi everyone, welcome to the Laser Channel. My name is Greg, and in today's video, I'm going to maximize my fun with the Monport 40-watt laser machine by installing this rotary unit to engrave some glass. Welcome back, and thanks for joining me for another video on the Laser Channel. You know, this Monport 40-watt laser machine has been absolutely a blast for me to use. Each time I come out to use this machine, it just works, and I love the versatility of using a CO2 laser source. Installing a rotary unit like this on this K40 style machine, it can be done. However, it's not something that's done very widespread, and that's because there's a number of roadblocks or challenges when combining a rotary unit with a K40 style machine. And in this video, I'm going to show you what works with my setup, and I'm also going to show you some of the roadblocks that you might encounter. So by watching this video, you'll know what to avoid and know what works. The star of the show, of course, is going to be a rotary unit and this K40 style laser machine. Now, the rotary unit, there's a lot of variety of these on the market, and what I'm mainly looking for is something that has a very low profile and something that has a smaller motor, something in likeness to the size that's found on this machine. This rotary unit is from the world of laser diodes. I recommend finding one from a reputable manufacturer that includes a couple of cables. This particular unit came with 2 sets of cables, and one of those sets of cables has some white ends on it. The other set of cables has black ends. And this will come up later on, but I'll tell you about it right now. And that is, if you have one set of cables connected up to the machine and you find your rotary unit just buzzes or vibrates, switch out to the other cable, and then you should have some nice smooth motion off of your rotary unit. Here I've got another high quality rotary unit from a reputable manufacturer. Now, even though this works great on a laser diode machine, it's not going to be a good fit on this K40 machine, and that is because this rotary unit here stands far too tall. Once I place an object on top of here, I just won't be able to get the workpiece in focus with the laser machine. That's why one of the main things to look for is a very flat or low profile rotary unit. Here I've got another high quality rotary roller unit, and as you can see, it's going to be far too tall. It's way too large to even attempt to fit it into this machine. And we'll also see that the motor that drives the roller unit is much larger than the motor that I first showed you on this roller unit. Now, even though this machine might be able to drive this motor, I wouldn't recommend it. You run a high risk of burning out the controller board running your laser machine. I have selected an appropriately sized roller unit, and it's now time to talk about the laser machine. And this is a K40 style CO2 laser machine, and it is by far one of the most popular CO2 laser machines on the market, and that is because the really low price point. This is absolutely the cheapest way that you can get into a CO2 laser machine from a reputable manufacturer from Monport and get nice quality results. Now, because this machine has been in production for a very long time, and there's many different manufacturers of a K40 style machine, there's going to be a lot of different variations between the machines. What we're going to be looking for is access in the work area that we can get to the very bottom of this cabinet. The other thing that we're going to look at is the controller board to make sure that the connector from the roller unit matches up to that controller board. Now, most of the controller boards are going to have this small little connector that looks like this, and I'll show you a close-up in a minute. There's a couple machines on the market that uses a ribbon cable, so you'll want to check somewhere in your machine if you can find connectors like this from the motors that move the laser head around. Let's take a close-up look at this connector. Here's the end of the connector that will be plugging into the controller board, and we're going to see that it's only going to be 4 spaces wide. The other end of the connector looks like this, and this is what plugs into the rotary unit. Let's talk about the main machine. I'm going to show you what that work area looks like. I'm going to show you what the controller board looks like on my machine. Now this is the base model Monport 40-watt laser machine. The controller board on here, I removed that and replaced it with the Monport motherboard version 2. This motherboard makes it Lightburn software compatible, and that's going to make adding a roller unit to this machine a real breeze. Let's take a look inside the work area and see how the roller unit is going to fit inside. On my laser machine, I have this access panel. It's held in place with 4 screws that I've already removed, making easy access of removing this panel so that I can now touch the very bottom of the case of the laser machine. If your machine doesn't have this access panel, you'll just have to figure out a way to remove this top plate, but eventually what you want to be able to do is place the rotary unit all the way down on the floor of the cabinet. This will allow me to slide the rotary unit in place, and I can take the cable and fish this all the way over to the controller board located over here. Here's an awesome top-down view showing that I use the opening of the access panel here to basically square up the rotary unit. I routed the wire underneath the framework here, and I go through this round access point right here. I'm making sure that this cable from the rotary unit doesn't interfere with any of the movement of the laser head. That cable is going to be connected up to the controller board right here, and let's take a closer look at that right now. There's a number of different connectors going up to it, and a brief explanation is this connector here with the white wires, this is typically from the limit switches on the laser machine for the homing. This large connector here with the big thick wires, that's going to be for the power to power up the board. And then there's going to be a smaller cable here, and this typically goes up to the power supply for the laser tube, and this is going to be the signal going up to that power supply for the intensity of the laser beam. And then there's going to be 2 4-pin connectors, and that's going to be for the x-axis of the laser machine and the y-axis. Most boards are going to be labeled whether it's the x-axis or the y-axis. However, if your board is not labeled, you'll just have to pick one or the other to see if it works, and if you pick the wrong one, just power your machine back down, plug the connectors back in, and you've guessed it, switch over to the other connector. For my machine, I know that this is the y-axis, so I'm going to unplug that connector, and here's the connector from my rotary unit. With that plugged in, I'm ready to power up the machine, and we'll start our calibration in Lightburn. Before I power on the machine and connect with Lightburn software, I want to talk you through how I'm going to be doing the calibration of the rotary unit. That way, when I engrave something like this glass jar, the shape that I'm trying to engrave turns out correctly. And by that I mean, without a proper calibration, my graphic might be really squished together or it might be really stretched out. So what I'm going to do is measure the diameter of this glass jar, and from that I'll be able to tell the distance all the way around this glass jar. Of course, that's the circumference. And in Lightburn software, there's a calibration screen that I'll take you through step by step. What I'm going to do with this circumference distance is I'm going to draw a box in the Lightburn software, and I'm going to engrave on the glass jar that box. And because that box is going to be the exact distance all the way around, I want the ends of that box to just barely meet up. When I first install a new rotary unit, I oftentimes will find the ends of that box are either not meeting up or they're overlapping by a considerable amount. and I need to adjust that setting in the Lightburn's calibration software so that they just meet up. Now, this is a nice glass jam jar that I've got, and I don't want to continuously etch or engrave onto this. So while I'm doing this test calibration, I'm going to wrap the jar with some common blue painter's tape. I'm going to run at a pretty fast speed at a very, very low power level, something just powerful enough to get the laser to fire. That way I'm just marking the tape, and when I'm done with the calibration, I can peel the tape off and I have a perfectly clean glass jar that I can engrave on. Now I'm ready to jump into Lightburn software, and I'll show you step by step this calibration setup. I've already measured the diameter of this jar, and I'll show you where to type that in the Lightburn setup. Inside Lightburn software, I'm already connected up to the machine, and what I want to look for is something in this area to enable, of course, the rotary unit. If you don't have a little menu selection right here, just navigate over to Edit, Settings, and there will be a little checkbox here, Show Rotary Enable on Main Menu. I'll turn that on, click OK, and now that appears. I'll turn that on, and now I can click on this icon up here to enter the rotary setup screen. Here's a brief rundown. I have the roller selected because that's the style of course that I have installed on the machine. I have it already enabled, and I have it hooked up to the y-axis. The x-axis, of course, is the laser head moving in this direction, and the y-axis is the back and forth direction. The roller diameter. This is going to be the diameter of the drive rollers that are going to spin your project material. In this case, mine are 17 millimeters, and again, these are these long rollers here. Just measure the diameter and put that in. Next is the millimeters per rotation. Now, this is the main thing that we're taking a look at in this setup screen. This is what we're going to use for the setup calibration on this glass jar, that when we draw this box that is the circumference of this jar, that it meets up. If it falls too short or it overlaps too much, this is the number that we're going to adjust to make sure that the ends of that box line up just right on this glass jar. When I measured the diameter of this jar, I got 70.1 millimeters. Yep, you really do want to measure this as accurately as possible for the best results. I'm going to take that diameter number that I got and put it in the bottom section here. And this whole bottom section here is just a calculator for us. So I've got that entered in, and it automatically tells me their circumference. So I'm going to highlight just the numbers in this box and right click and copy. And I'm going to use that number to draw a box in the work area. Here, I'll show you what I mean. Here I'm going to draw just a box right now. And I'm going to come up to the top here and unlock this padlock so I can adjust the width and the height separately. And it's this height that I'm going to use that's going to be the test engraving on this blue tape all the way around. I'll highlight everything in that data entry box, and I'll right click once again, and I'm going to paste that number from the previous setup screen. Now the width of 8 millimeters, that's a little bit too wide, and I think something more like 2 millimeters will be just perfect. Before I place the jar into the rotary unit, there's one more thing that I want to change in Lightburn software, and that is the start from position. Normally I have my machine set in absolute coordinates, but because I'm using a rotary, I want to set it to current position. Next, I want to manually move the laser module head up close to the limit switches. I just want to be close to them, and I don't need to hit the limit switches. And now we can jump back into Lightburn software, and I can show you what I'm going to do next. Because we're in current position, the laser head doesn't really know where it is in the Lightburn software, so we're going to manually tell it where we want it to be, and that's going to be the center of the workspace. And on a K40 machine, on the x-axis we have 300 millimeters, So I'm going to take half of that and type in 150 millimeters, and on the y-axis, 200 millimeters. And again, half of that will be 100. And I can tell it to go to that position. We'll also see on the work area in Lightburn software, here is a little indicator where Lightburn thinks the laser module is. And I can just take this here and place that about in the middle. And because we're in the rotary mode, it's okay if objects extend outside of this normal work zone. Now I can place the glass jar on the rotary, taking note that it's facing off towards the control panel, and now I can manually move the laser module into just the right position. This looks good, and I can close the lid and do the first calibration test. For this test, I have the laser mode in line. I've got the speed set pretty fast at 85 millimeters per second and the max power at 11%. Again, I just need just enough power to mark the tape. And here's where the ends of the box meet. So I have a perfect calibration on it. We'll see that the line width is a little different from side to side, and that's because of the tape. I found when it's in the roller unit, this provides a pivot point while it's in there, and it has a tendency to rock back and forth. Without the tape though, these lines would be, of course, the same width. The last thing that I'd like to do when I do a calibration is I like to draw the number 3, and let me close this out, and I'm going to delete this calibration box. I want that number 3 to be rather large, and I'm going to type that in. And I need to rotate the top of the 3 so it's going to be towards the top of the jar. So on my machine, I always have the top or the opening of whatever I'm engraving facing towards the control panel. So I'm going to do the same thing in the Lightburn software. I'm now at perfect 90 degrees. I can place the jar back in there, and what this calibration is set up for is to see if the 3 comes out the correct direction or if it's reversed. If it's reversed, I need to go back into the rotary setup screen and check the mirror output to rotary button. Here's my number 3. It is facing the correct direction, and we'll also see that the width to height ratio matches what I have drawn in the Lightburn screen. This completes the setup and calibration of the rotary unit in a K40 machine. And I just wanted to mention that during that calibration where we had that setting of the millimeters per rotation, that only has to be done once. Even if I place an object that's a different diameter in my roller unit, I still keep that same calibration number in there. This is the really neat thing about using a roller unit. The other really neat thing is using this blue painter's tape. If you're having troubles with the calibration and you need to do multiple test engravings like I need to do off camera before I prepare for this video, I can just peel this tape off and put another new piece of tape on. Well, I think I've got a little bit extra time to do an actual engraving on this glass. Back inside Lightburn software, I have the channel logo graphic loaded into the workspace. I've rotated it 90 degrees so that the top of the logo is going to face the top of the jar. We'll also see that under cuts and layers, I've changed the mode from line to fill for this engraving. I've also increased the speed to 125 millimeters per second, and the power level increased only slightly to 14%. That's correct. A 40-watt laser machine like this Monport has no problems engraving glass. If you're coming from the laser diode world, this would be the part where I'd have to put, of course, black paint or something on this glass for it to accept the engraving. But with a CO2 laser, I can put this bare glass into that rotary unit and the laser will have no problems engraving it. With that, I'll place this in the work area and let's watch some nice relaxing engraving. The engraving turned out absolutely perfect, and it only took a couple of minutes. The last thing that I'll do before I'm finished with this is, because the laser does such an awesome job engraving glass, it does leave kind of a rough texture. So what I like to do is I take a glass of water and then some sandpaper. This is silicone carbide sandpaper, or more commonly known as wet dry sandpaper. And I think this is 600 or 800 grit sandpaper, so something very fine. I just get that sandpaper wet, and I actually pretty aggressively sand over the top of that engraving to make sure that it's nice and smooth. Once I'm satisfied with that, I wipe it down with a clean paper towel, allow it to dry, and it's now ready. Thanks for joining me in this video as I maximize my fun by installing a rotary unit on my Monport laser machine. This really does open up a world of possibilities that not only can I engrave glass now on that rotary unit, basically anything that fits on that rotary unit I can now engrave. So a pretty cool thing that I'm able to do without modifying any of the wiring or mechanically cutting holes or anything like that on the machine. This takes just a minute or two to get set up, and it also takes just a minute or two to put everything back the way it was. Thanks for joining me in this video. If you enjoyed the video, please consider giving it a like, subscribing to the channel, or ringing that notification bell. That really helps the channel out, but more so, it's a great way of connecting content like this with viewers like you. Until next time, learn, create, and share.